to talk about sets of numbers today. We're going to start off with the concept of looking across the plain back in very olden days when we were hunter-gatherers and looking at how many antelope are out there. We're going to start counting those antelope. Of course, when we start counting with the number 1. 1 antelope, 2 antelope, 3 antelope, 4 antelope. We are not paying attention to the half-eaten antelope that the lion killed. We're not interested in that. We're only interested in the ones that we can kill because we're not going to take that antelope away from that lion. Right? So we grab those numbers. I would call those counting numbers. Okay? Or natural numbers. And then somewhere, I don't know, about 1,000, 2,000, 3,000, 4,000 years ago, out in India, and Pakistan, and Iran, and Arabia, that area of the world, somebody came up with this concept of not seeing any antelope out there on the plain. And they came up with a symbol for that, of not having something. And they came up with this symbol. The symbol for 0. The concept of not having. This was big stuff, guys. It meant adding and subtracting got a whole lot easier. Computing got a whole lot easier. And we grabbed that symbol and we added it to our counting or our natural numbers, and we called these whole numbers. Whole numbers because we're not counting the half-eaten antelope that the lion's eaten. We're talking about the whole thing. And so somebody came along and said, it means I have this, I can put these numbers and organize them on a number line. But what if I put a mirror up and I wanted to look at my number line going in the opposite direction? Right? I have a number line going in the opposite direction, but how do I know that they are the opposites of going in the right-hand direction? Well, we're going to symbolize that with a dash and call those negative numbers. Now we have negative numbers and positive numbers, and 0 sitting in the middle, and we grab all of that together. We grab all that together and we call these integers. Alright? So we grab the integers. Notice, okay, I still have my whole numbers inside. I still have my counting numbers inside of my integers. Now somebody came along and said, you know what? I can see that my set is represented by these dots. Well, what about the stuff that's in between the dots? Like that half-eaten antelope, or maybe that's a quarter of an antelope by now. What about those numbers that can be represented by parts? Okay, like 1/2, 0.5, or 1/3, which is represented by 0.33333 forever. Or say -1/4 or negative 0.25. Right? Those numbers that can be represented by a ratio or a fraction with an integer over an integer. What about those numbers? They start filling in our number line. Okay, well, these numbers, okay, can be represented. And don't forget that we could also represent 2 over 1, which is just like saying 2. So I still have my counting numbers. All right, so I'm going to grab all of that together, and I call these the rational numbers, with the word ratio meaning fraction. All right, so I grab all those together, I group them again. But what about those numbers? And this means I'm filling in my number line. Okay, that number line that I have, I'm starting to fill in between numbers. But I still have holes in my number line. I still have holes in my number line. And I'm going, oh gosh, all right, but what about this number here? The square root of 7. Okay, it cannot be represented by a fraction. What about pi, which is 3.1415926 something something something? It can't be represented by a fraction. Now, the square root of 4 is not in this set. The square root of 4 is actually hanging out over here in the natural numbers. You go, why? Because the square root of 4 is 2, and 2 is a counting number. So I take this set of numbers that are not rational, and I call them irrational, with a stress on ir, meaning not rational. And I take that set of rational numbers and irrational numbers and group them all together, and I call them real numbers. And now I have filled in all the holes on my number line. And so my number line, when I go to graph it, I can actually graph and color in between numbers because I'm including everything on the number line. I don't have any holes because they've all been filled in either by a rational number or an irrational number. Now, there is another set of numbers on top of this. There is another set of numbers on top of this, and they're called imaginary. Imaginary. Yeah, there's another set of numbers out there. And that when I grab the imaginary numbers, we're going to talk about those and what they mean. We grab those imaginary numbers along with our real numbers, and we grab all of this, leaving nothing out, and we have something called complex. Now, think about this a little bit, answer some questions, write down your questions if you have any questions, bring them to class. I'll be happy to talk with you. Y'all take care. Have a good day. Bye-bye.